In the previous video, we explained the idea of implicit differentiation. That idea can be used to solve related race problems. Let's take a look at this example. Suppose a particle moves on a circle, x squared plus y squared equals 25, and its position at a time t is given by x, y, and these are really functions of time t, so x equals xt, y equals yt. Suppose we know that dx dt equals to 12 at this particular point. We want to find out dy dt. Before we solve this problem, let's take a look at the picture and see whether that helps us to understand the situation. So here is a picture of the circle, and our particle moves on this circle, and the point of 4 minus 3 is right here. And here is the velocity vector of the particle. The velocity vector should be tangent to the circle, right? And that vector has x component and then y component. And these are exactly equal to dx dt and then dy dt. So the question is, suppose you know the size of this component, x component, we want to find out, how big the y component of the velocity vector is, okay? Well, let's apply the same idea as before for implicit differentiation. There we took a dx on both sides of the equation. Here, the situation is slightly different because x and y are functions of t, okay? Unlike previously, we treat y as a function of x. There was no t involved. Therefore, instead of taking dx on both sides, we're going to take a dt on both sides, okay? So we look at this equation here, and we're going to take a derivative with respect to t. And keep in mind that x is really xt. X is a function of t, and same for y. Therefore, you really should think about this equation as the follows. Xt squared plus yt squared is equal to 25. All right. Now, when you take a derivative with respect to t, you have to use the generalized power rule. Therefore, this x squared derivative becomes 2x and then times dx dt. So this is the derivative of x squared. And similarly, derivative of y squared gives you 2y dy dt. And then derivative of 25 is simply equal to 0. All right. And there you can solve for dy dt once you substitute those values into the equation. So x equals to 4, dx dt equals to 12, y equals to minus 3, and then you can easily solve for dy dt, and that's it. Let's take a look at another example. Here we have a water tank that looks like a inverted circular cone. So here's the picture here. Suppose the base radius is 2, the height is equal to 4, and we have water that is being pumped into the tank at this rate. And suppose currently the water level is 3 meters deep. We want to find out how fast this water level is rising. So suppose if you denote the height to be h, then basically we want to find out what is dh dt. Okay, let's start with assigning those variables. So v denotes the volume, r is the radius, h is the height, and t is time. And let's look at the relationships between them. So first of all, there is this well-known volume formula. Volume for a cone should be equal to 1/3 area of the base times the height. So 1/3 pi r squared times h. We also know that dv dt equals to 2 because this is how fast the water is being pumped into here, so the volume is increasing at that rate. And h is equal to 3 currently is 3 meters deep. And we want to find out what is dh dt. Okay. Now, this picture does provide a connection between a relationship between R and H. Basically, we have two similar triangles. The bigger triangle right here, the right triangle here, and then the smaller right triangle here. Because they are similar, we should have proportionality between their sides. In other words, if you take R over H, that should be the same as the ratio of those two sides, which are 2 and 4. So R over H is 2 over 4. That gives you the relationship. R is equal to 1/2 H. So once you substitute that into the formula for V, then V becomes a function of H only. So V is 1/3 pi times, you substitute 1/2 H here, H squared times H. And then 1/2 squared is 4, 4 times 3 is 12, so pi over 12. And then H squared times H is H to the 3rd. So now we can look at this equation here, and we're going to take a d dt on both sides of this equation, and that will allow you to solve for dH dt. When you take that d dt, so dv dt is just dv dt, and here you keep the constant, and then H to the 3rd, you have to use generalize the power rule. Okay? Therefore, we got dv dt is pi over 12. Generalize the power rule says 3h squared, so bring the 3 to the front, then subtract the 3 by 1, so you got h squared, and then you have to multiply by dh dt, and then you cancel out 3 and the 12, you got a 4 here. Okay, and now you can substitute the numbers into the equation. So dv dt equals to 2, and h equals to 3, and you got the equation here, and then you can solve for dH dt. So notice 2 times 4 is 8, and this is 9 pi. So dH dt should be 8 over 9 pi, which is approximately 0.28 meter per minute. Let's look at one more problem. Suppose we have the intersection of two streets, and we have two cars, A and B, that are traveling towards the intersection. Car A is currently 4 miles from the intersection and traveling west at 25 miles per hour. Car B is currently 3 miles from the intersection and traveling at a speed of 30 miles per hour towards the intersection. The question is, at what rate are those two cars approaching to each other? In other words, if you let z denote the distance between A and B, then the question is, what is the rate of change of z with respect to time? Okay. Well, first of all, let's set the variables. So we simply denote x, y, z be those three distances. And then by Pythagorean theorem, we have an obvious equation between x, y, and z, that is z squared is equal to x squared plus y squared. Here we should assume that the two streets are perpendicular to each other, and therefore we have Pythagorean theorem. And then we also have this the figures that we already know, which is x equals to 4, y equals to 3, and dx dt equals to negative 25. It's a negative number because x is decreasing, and dy dt is a negative 30. So the question is, what is dz dt equal to? Okay. Well, we can simply take derivative with respect to t on both sides of the equation, and keep in mind that z is a function of t, so z is zt, and same for x, x is xt, and y is yt. Therefore, when you take a derivative, you need to use the generalize the power rule. So like z squared would give you 2z times dz dt. Okay, so 2z dz dt, and then x squared will give you 2x dx dt, and then 2y dy dt. And now you just substitute all those numbers into here, so we already know what x and y are, and dx dt dy dt. We still have to figure out what z is. Well, that should follow from this equation. So so z squared is equal to x squared plus y squared, but x is 4, y is 3, and then from there z is equal to 5. All right, so now you substitute all the numbers into the equation. So we have the following. I did cancel out the 2 from both sides here. So z gives you 5, and x gives you 4, and dx dt is minus 25, and so on. So from there, you can easily solve for dz dt. And that's the answer is minus 38. Notice it is a negative number because the distance is decreasing. So they are approaching at a rate of 38 miles per hour. That's it.